Hello and welcome. In this video I will do an algorithm for generating a spiral matrix. Okay, what this video is about? Well, my idea is to explain you how to think for this kind of problems, okay, and I want to teach something, so I made the algorithm readable and you can learn and understand my idea, okay. And also I did had not any concern about performance, or alright. So let's start. Our first problem here is generating a 5x4 matrix that starts at the bottom left, and it does this kind of effect until it reaches the number 1, our goal. So at the first glance this can be difficult, right? And you watch this kind of problem and you don't know what to do, right? So let's see the matrix in this way. We can have a layer, right? And then we can have another layer. We can navigate in this layer, and then we can navigate in this layer. So this suggests at least one cycle, okay? If I go to the code, and I already have some code set up to make a empty matrix, and you will see a zeroed matrix. Okay, I have a 5x4 matrix, and the matrix appears because I have this method, okay, that prints the matrix. Is just that. And going back to our problem, I said we have a loop, so I'm put here while true for now, okay. So the next thing, what to do in each cycle? Well, we can navigate in the x coordinate and in the y coordinate and x again and y coordinate. So we have here two concepts. The first one is the coordinates x and y, and the second one is how many steps each coordinate can navigate, okay, in. And also we have inner cycles. If you notice, this can be one cycle, this can be another cycle, and the third and the fourth cycle, okay. So let's apply these ideas in our code. The first one is creating our coordinates. We have an x coordinate that starts at 0 at this position, and the y coordinate will start at the number of rows minus 1. So going back, y is equals to rows minus 1. Our second concept is how many steps we can move. For the x is the number of columns minus 1, because we can't go, okay. So going here, let's call it x steps is equals to number of columns minus 1, and the y will be something similar, but instead of columns will be the number of rows minus 1. So let's move here and call it y steps equals to rows minus 1, okay. And we have 4 inner cycles. I will use 4 loops, okay. For int step that is equals to 0 and the step must be less than x steps, step will increase. Okay, so this for loop means this. Okay, we are navigating in this direction. Let's make the matrix at y x plus plus, and it will be equals to the number that I did not declare. Int number is equals to the number of columns multiplied by the number of rows. So minus minus, because we are decreasing, right? So this for loop means we are here 20, 19, 18. Okay, next we want to move here. We have another loop. Okay, let's copy this one, but instead of moving in the x steps, we need the y steps, right? And instead of increasing the x coordinate, we are decreasing the y coordinate. Looking again to the slide, next we have another loop, but in the x position, and we are decreasing the x, and in this fourth loop we are increasing the y. Okay, so going here, we copy these two loops. Oops, I copy and paste like this, but here instead of increasing the number, the x, we decrease the x, and here we increase the y. Okay, so we end this loop, and since we have this x step and y step, we can now remove this and say that while x step is bigger than 0 or y step is bigger than 0, this loop will run. Okay, also let me show you. Well, the next thing, we must prepare our next iteration. Okay, we must first update the position of x and y. Okay, so we moved here, and then we must update the x steps and y steps because this decreased, right? This is a smaller matrix. So going here, we will increase the x because the x is moving in this direction, and we will decrease the y. Why? Because the y coordinate is moving in this direction. So move the x to this direction and move the y to this direction, and we reach this position. Okay, now the x steps and y steps. Well, this inner matrix lost this column and this column, and then this row and this row. So we in the code do something like x steps will be equals to x steps minus 2, and y steps will be equals to y steps minus 2. Okay, so we have our first version of the algorithm. Okay, so if I run this, we have this spiral matrix. Okay, is doing what we want. Let me see the I was talking about the inner cycles, and yeah, it works. And if you try at 4-4 and 4-3 and 3-4, it works. Let me show you 3-4, the last one. We have a 3-4 spiral matrix. Okay, but if we do this 2-5, it will not work. Let me go, let me show. I think this in C# this will generate an exception. No, this is not working, and we have strange values here. Okay, so let's understand what is happening. We have this problem, 2x5 matrix. Okay, we start with x steps equals to 4 and y steps equals to 1, and we do this, and then this, and then this, and then the fourth loop here. The cycle ends, and we update these values. Okay, so the x steps is equals to 2 and y steps is equals to -1. In the while loop, we are saying that while x steps is bigger than 0 or y steps is bigger than 0, this loop will run. Okay, so and also we update the x and y coordinates, okay, to move to this position. Okay, well, since x steps is 2 in horizontal inner cycles will execute. This means this cycle and this cycle will run. Okay, so we will affect these values here, and these values are compromised. This is our problem. So instead of x steps bigger than 0 or y steps bigger than 0, we can try x steps bigger than 0 and y steps bigger than 0. Okay, so let me change in the code. Here instead or we use a and if we run this, now we get our matrix, spiral matrix working. Okay, again, so it works. But if we try the 3 and 4, let me show you 3-4. Oops, because this is running 3 and 4. Let's run this, and these values are empty. Okay, so what happened here, right? Well, sorry, I have here the answer. X steps are 2. We went here and here and move here and move here. The x steps and y steps were updated, and x steps is equals to 2 and y steps is equals to -1, and since we have a and, okay, the loop will stop, and we don't update these places. Okay, so we can take advantage of knowing how many positions we already reach, because we have x and y coordinates and we are decreasing until we reach the maximum inner cycle. Okay, so we can have another two concepts. The first one is the visited, and at the first time we have 0 visited, and we have the total, that is the number of columns multiplied by the number of rows. Okay, so instead of while steps bigger than 0 and y steps bigger than 0, we have the visited less than total. Okay, so while the number of visited places is less than total, we continue, okay, in this loop, and we must update these values. So in every cycle, every inner cycle, we must do visited plus plus. Okay, so let me copy, let me paste. Okay, so we update the number of visited, and also we must put here a check for the number of visited less than the number of total. Okay, in each cycle we have these conditions. So what I added here, the number of visited, check, and the update of visited. Okay, and in the while I have this check. Okay, so it runs. If we run this, let's see, we now have our spiral matrix working again. Okay, and this is cool. We have this happy cartoon. So if we try this 3 by 3, let's see, instead of 3 by 5, and it's running, instead of 3 by 5 we have 3 by 3, and we run, and something happened, and Visual Studio will, the program will run forever. Okay, so I close this and let's understand why. So we start here and we go here and we go here and we go here, and x steps is equals to 0 and y steps is equals to 0, and nothing happens. Why? Because each inner cycle is checking about this. So if x step is 0 and if we start at step 0, 0 is less than 0, no, so this condition will fail and this for will not run, and this for too, and this too, and this too, and it will update and go to the next loop and do the same thing, fail, 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 and fail, and update again, and so on. Okay, so this is a special case, a special scenario where visited is equals to total minus 1. So we must add a special condition here. Okay, if if visited is equals to total minus 1, okay, matrix at y minus 1 and matrix at x plus 1 will be equals to the number, okay, and then we will break this loop. Okay, we have this condition because we have one place that we didn't visited, right? So and now if we run this works again, okay, and we have a super happy cartoon about Sparta. Okay, one thing to notice here, this is a special case because it is an odd number. It is an n by n matrix where n is a odd number. Okay, so this is it. Thanks for watching and hope you like it.